System of equations. Osvaldo, today your objective is to learn how to solve them by graphing. Graphing is one method. It's really inferior. It's not the way to go. But you need to know how to do it. And we'll show you, because it's pretty easy. Tomorrow we'll show you the fast ways. A system of equations is two or more equations. Here we go. You need to graph them, both in the exact same coordinate plane. So these are easy because they are in y equals mx plus b. Say, give me the m and the b of this guy right here. M is -1. What's b? Okay, let's make -1 rise over run. So it's -1 over 1. And b is -2. So Joel, what do we do with our m and b? Give me a dot. Where's my first dot going? Okay, where's it go, Joel? On the y, -2. Everybody put a dot right there. Now where, Joel? You got to use your rise over run to get more dots. Where do I go? Huh? Left one, up one? That'll work. Left one, up one. Or you go down and right. Either way. Okay, once you got a handful of dots there, draw a line through them. Alright, Kendra. Let's look at line number 2. So line number 2, I'm going to change colors. What is your M and B on line number 2?
-4 and 4.
Sweet. Where's my first dot go?
4.
On the X or the Y? The Y. 4. Put a dot there. Now use your slope to get some more dots. -4 over 1. So I'm going to go down 4. Right 1. Down 4. Right 1. Okay, you read ahead about the solution. What is the solution? Right here. What's the answer to a system? The point they have in common. What is the point they have in common? The solution is where they cross. It's their intersection. So how do I get to that intersection? I go over 2, down 4. That is your answer right there. That's the answer to your system, which is the exact opposite of the y-intercepts. Yeah, that's kind of weird. Coincidence. That's a coincidence. The ordered pair is the exact opposite of the y-intercepts. So, Marcos, you see all these dots? Each line has got an infinite number of dots. But if you graph them together, there's only one dot that they have in common. That's it. Does that make sense? It's where they cross. It's where they touch. Brandon, you alright with that? Okay, try this guy right here. What if they don't cross? That's a good question. Try this one right here. Try this guy. Okay, right here. Y equals 2x minus 4. This guy, what is the M and the B? What's your slope and your y-intercept? Slope is 2 over 1 and the B is -4. Okay, your B is your first point right here. So -4. Up 2 over 1. Up 2 over 1. Up 2 over 1. You got a bunch of dots. Now, let's do this bottom guy right here. What is the slope and the y-intercept of this one? Slope is 2 over 1. And you should know they are parallel. So if these guys never cross, you know they're parallel right here. Their M's are the same. Same slopes. So if they're the same slopes, that means they're parallel. If they're parallel, they never cross. So Melanie, where's your answer? The answer is what they've got in common. What do they have in common? They have nothing in common, so it's no solution. Well, they do have slope in common. They don't share a common dot, a common point. Okay, try this one. Try this one. This guy, what's the M and B of this one right here? 1/3. What's the B? Alright, B is your first point. So on the y-axis, put a dot at 2. Now go up 1 over 3. Go down 1, left 3. Okay, right here. Something like that. A little too curvy. Yeah, a little too curvy. Okay, now right here. Logan.
Yes.
What's the M and B of this one? We gotta find it. You cannot find it unless it is in y equals mx plus b. This is the beauty of mathematics. That is not how we want it, but you are strong enough that you can manipulate it into how you want it. So let's manipulate it. How are we gonna get y by itself? Plus x. Plus x. So you got 3y equals 6 plus x. Divide by 3. Divide each term by 3. 3 divided by 3 is just 1. So you got 1y. 6 divided by 3 is 2. And x divided 3 does not simplify. So just write x divided 3. Now Brandon, that's how we want it. We want y all by itself. So we had to force it, but it wasn't too much. What's M and B now, Brandon? B is 2. And M is 3. But 3 is on the bottom. So what's on top? Just an invisible 1. So M is 1/3. B is 2. That's the exact same line that we just barely did. You start at 2. You go up 1 over 3. Down 1 over 3. So this line lands exactly on top of this line. And your answer is where they touch, what they have in common. So Caitlin, what do they have in common? They have everything. So your answer is infinitely many solutions. IMS. His thing is this: infinitely many. Now, why does this not work? Why is this no good? How come you cannot put all real numbers? Yeah, because look, there's a dot here, and a dot here, and a dot here that are in the all real numbers, but they are not on that line. So it's not all real numbers. That's the difference between infinitely many and all real. Okay, this slide right here.